All right, now we're on page 3, questions 20 through 30. You have a graph that represents the elongation of a spring. So F equals Kx is what I would say is the relationship between the force and the elongation. It's straight, so it follows Hooke's law. How much work must be done to stretch the spring 0.4 meters? This is actually kind of a difficult question. We just talked about in the last video that work is the transfer of energy. In this case, we're transferring potential energy, so 1/2 kx squared is going to equal the work. The problem is we don't know what k is, and k you get from F equals kx. K is the slope. So the slope of this, if you do 24 divided by 0.4, you get, I should be able to do that in my head, you get 60. So you have to do 1/2 of 60 newtons per meter times x. Your x is 0.4 meters squared. So 0.5 times 60 times 0.4 squared. You get 4.8 joules, which is answer 1. Again, that's a very tough question. You have to know the definition of the work, not just force times distance. If you wanted to do force times distance, you could, but you have to recognize that the force is not constant, it's changing, so you'd have to pick the average force. So you could do 1/2 of F times D, and that would give you the same answer, I believe. Half of 24 would be 12 times 0.4 is 4.8. So that might be the easier way to do it, if you thought of that. But again, that's like an area under the curve question, which a lot of kids struggle with. Question 21, you have two identical wooden planks. So they're the same length, but they're at different incline angles, which I don't know how that could be. Great question. Oh, this one is lower. I see why, because there's this extra height here. Maybe if they shaded that a little better for me, I would see it. I don't know. Compare the amount of work done against friction by a block sliding down plank A. The work done against friction by a block sliding down plank B is. So the work done by B. So friction, force of friction, is mu Fn. And in this case, Fn, wow, this is a tough question, is Fg perpendicular, right? It's the same as Fg perpendicular. Are the blocks the same? Yeah, I think the blocks are the same. So Fg perpendicular is equal to Fg cosine of theta. So you can probably imagine too, just from the picture, that the shallower the angle, the greater the normal force, which the greater the Fg perpendicular, because if something is flat, all of the weight goes into the normal force. If it's at an angle, only the portion of gravity that's perpendicular goes into it. So in B, that's this one over here, you have a greater normal force. Friction coefficient would be the same because it's, concrete on wood, so that's not changing. So the fact that in B you have a greater normal force, you have greater friction. They're the same length, so your work, F times D is the same for both. So the greater work is going to go with the greater force of friction, which is B. So let's see. The work done against friction by a block sliding down plank B is going to be greater. It's going to be more. Next question. Let me erase some things as I'm reading here. Gravitational force F exists between 2 point masses. If the distance between the masses is tripled, the force between the masses will. So the equation that relates these two is big G m1 m2 over r squared. We call this our inverse square relationship. So whatever you do to r, you square it, but you also have to invert it. So if I'm tripling the distance, that becomes a 9, a factor of 9, but because it's an inverse, it's 1/9 as much the force. So F over 9 is your answer. All right, next question. A 5 Newton force imparts an impulse. Sorry, I'm erasing. Imparts an impulse of 15 Newton seconds to an object. The force acted on the object for a period of. So impulse is J, F times T. They're telling you the impulse is 15 Newton seconds. They're saying it's a 5 Newton force, and they want to know what's the time interval. Solve for T. T is going to be 3 seconds. Straightforward. You got to know your definitions and your reference table. A crate is pulled 6 meters up an incline with a force of 50 newtons. If the potential energy of the box increases 250 joules, the total work done against friction in moving the box is. So if it's 50 newtons times 6 meters, the work that should be done is 300 joules. Well, that is the work that's done. That should be done. The energy that should be transferred should be 300 joules. But it says the potential energy only goes up by 250. That other 50 joules of work was the work done against friction. So that's where answer 2 comes from. If the kinetic energy of this is 25, kinetic energy of a mass is to be doubled, its speed must be multiplied by. So again, you guys got to understand relationships. 1/2 mv squared. The relationship between kinetic energy and velocity is KE is proportional to v squared. So if you want KE to be 2 times, if you double your velocity, you're going to get 4 times. If you have your velocity, you're going to get 1/4 as much. So what number doubled would give you a 2? Radical 2 doubled. Excuse me, not doubled. Squared. Square relationship would give you a factor of 2. So the answer to that one is 3. Sorry for misspeaking there. All right, 26. A rocket in space can travel without engine power at a constant speed in the same direction. This condition is best explained by the concept of, so you don't need power because the object is already in motion. As long as it's not acted upon by an outside force, it will continue to move in a straight line at a constant speed. That concept is Newton's first law, and it's the first law of inertia. It's just a definition. All right, next, 27. 700 watts of power is needed to keep a boat moving through the water at a constant speed. What's the magnitude of the force? Power is work over time, which is force times distance over time, which distance over time is F times V. All of these are in your reference table. You're given power, you're given V, you just have to solve for F, and I believe it's 70 newtons if you do the math. 28, energy is measured in the same units as work. Work is equal to the transfer or change in energy, so that one is work. Constant unbalanced force of friction acts on a 15 kilogram mass moving along a horizontal surface at 10 meters per second. If it's brought to rest in 1.5 seconds, what is the magnitude of the force of friction? So anytime you have change in velocity and time, mass, and you want to know the force, just writing it out, I hope you see that you want to do MAVFAT. F delta D is M delta V. So you have, you want to know the force. You have the time is 1.5, the mass is 15, and it's brought to rest, so your delta V is 10. It's actually negative 10, but all the answers are positive because it's looking for magnitude. The word magnitude just means the number. So this divided by this, whoops, I want F. So I divide 1.5 over 1.5 over, that gives you a factor of 10, 10 times 10. F is equal to 100 newtons. So the answer is 2. All right, last question. I only have 20 seconds to do it. A force of 3 newtons and a force of 5 newtons act concurrently to produce a resultant of 8 newtons. 3 and 5 equals 8. The angle between them must be 0. They're in the same direction. Okay, remember, you can put 3, 5, you can put the 5 in any direction. If you put them in line with each other, 0 degrees, you get a maximum. If you put them opposite each other, you get a minimum.